don't you come along with me? I'm going to design, build, test fly, and work out the kinks on my very own custom paramotor. So here it is. I acquired my materials through a couple of sources. I got some of it through the mail for the smaller quantities, and I also acquired some in a nearby town that had a steel yard, and they custom ordered some aluminum for me. I wanted the motor mounts to be as strong as possible. I wanted a backbone built into this frame, so I thought the angle would be a good candidate to weld together. It would be tight. I made some motor mounts and cut those out of some more smaller angle, and I measured everything so that it would clamp up nicely, and that's the trick. If you'll clamp things up nicely before you stick them on there, they'll be where you stick them on there, and then it's just a matter of setting them up exactly where they need to be, welding them again, and if you get everything square and put together right before you stick it, things hold really well. I knew from my initial calculations that I had to make room in this frame for a pull start rope, and I just need to fit it up and figure out exactly where it comes through. I calculated the middle and I was right, so I was marking it, cut it on the bandsaw, make some room for it. Yeah, looking good now. I wanted a lot of strength on the frame. I wanted a good solid connections from the motor mount all the way through to the wing, but I also had the problem of putting fuel in this frame, so it has to be fuel tight. So I made these nut cups so that I can get to the nut on the back side of the swing arm attachments. And basically it's just like building a puzzle and putting the pieces together and sticking them where they need to stick. My design incorporates an off-centered motor mounting option, so I had to build the thing a little off-centered. This arm's going to stick out a little further than the other one, and I measured it, cut it, clamped it, and welded it just like I needed to do. TIG welding aluminum requires everything to be really clean. The more you have it just pure metal, the cleaner the weld is going to be. In the beginner-mediate stages of being a welder, I dip the tungsten sometimes, so I've reground them a few times. The more I do it, the better I get. It's always quite refreshing when your parts end up being just the way they're supposed to be. Boom, 14 inches. It's what everybody's going for, right? Being a first-timer, I thought I would use this as a learning experience. I figured, I know metallurgy, I know how to weld, I know how to machine. What's the thing I can't bend it and make it work? So I did some studies, did some calculations, figured out what's possible, what's not. Of course, YouTube. I use some YouTube videos. Love these things. And here I am taking my design that I drew and transferring it over to the sheet. Project comes to life. Failed geometry in high school because I didn't do my homework. I made 100% on all the tests. Thank you, Miss Applegate. That stuff did come in handy. But for some reason, I always knew geometry, and it made sense to me, and I refused to do the homework on something that I already knew. Some of the bends intersected each other, and I couldn't use the brake to get the proper bend on it, so this is the solution I came up with. It's what's known as cold forging. I need a way to access the motor mounts through the frank, so that's what I'm trying to do here. Just use some lighter material and make a window so that I can get to the back side of those motor mounts to tighten or loosen nuts or just whatever. General access for the starter. Got to cut it out after all that. It's a frame, it's a tank, it's a frank. So I've got to use this little scrap piece of aluminum here that I use for something else to make the rest of the clearance for the starter rope. So a couple of crafty bends, a little check on the measurement. I got real lucky with my bends. I didn't really have to redo anything. Everything more or less worked out the first time. I might have had to change a bend here and there while I was working on it, but you can go back and forth at least once or so with this stuff. And then it was just a matter of sealing it up nice and tight with the welder. You do not want your parts to move. When you get them where you want them, you want to have them there. And it's always interesting to come up with a clamping solution for whatever it is that you're doing. And having lots of clamps, lots of space, you do what you got to do to make it happen. Once you get it tacked up, good. A common solution to judging fuel in an aluminum tank is with a sight tube. So I decided to go that route, and just a piece of aluminum tubing, little thin stuff, 1/4-inch aluminum tubing. I decided to make me a sight window so I could see the last couple of gallons of fuel was my guess. And just picked a spot, put it in. The main fuel tank component was going to require multiple bends, multiple directions, and I just didn't know if I could do it. But you know, it's just like anything. You measure and cut, you measure and bend. Measure, eyeball it, think about it. Just take your time and do it right. Sometimes I didn't make a bend that was long enough. That one worked out perfect. The next one, actually I shorted it a little bit. It's always better to short it. You can go back and add a little bend if you need to, just like I needed to do here. Wasn't quite there. Boom, just a little tweak in the bender. There you go. You kind of guess how much you need to do it. Third bend. Are we going to do it? Is it going to work? No, little shallow. Always better to go shallow. Look at here. Boom. Lined up nicely. This was the final product. And then installed. Ready to be tacked on. Got the tack up done. All that's left to do is zip it up. Once I got the welding out of the way, it was time to check it for leaks. So I had to finish the install of the sight tube, the fuel tube. It was time to determine if my math and geometry skills were up to snuff. So this is, of course, how anybody would do it, right? Count how many milk jugs it takes to fill it to the top. So I was perfectly accurate. 5 gallons maximum capacity. So once I got the measurements confirmed, it was time to check it for leaks. The problem I ran into is it was cold. That water was so cold that everything instantly started sweating. So I had to use warm water from the kitchen sink. And I did have several leaks. I fixed them all. There's a lot going on with the lid of the Paramotor. I've got to have a clearance for the starter rope. I've got to have a fuel cap. got to have a fuel pickup access. You gotta have two up tube supports for the up tubes, and I gotta have two brackets to mount the harness to at the top corner. So there's gonna be a lot going on. I've got clearance issues. There's a lot of designing that happened inside my own mind when I was putting this thing together, and I didn't write any of it down. You just have to take my word for it. It's all where it needs to be, and it's time to get to it. I guess it's my love of helicopters, or my childhood fascination with them. I decided on a helicopter style landing skid, and just gonna fab it up out of some tube, stick it on, put some skids on it, and there you go. I figured that titanium would be a good option for mounting the harness with removable pins, so I had a piece of 1/4 inch I've been saving for some kind of project, and I thought grade 5 titanium with an aluminum support bracket would be a good option. So I drilled out some holes, and what I did here is I drilled this hole bigger, and I just put a peck mark on the other side just to line up the next operation so that I wouldn't have to refine the center. I just used a hand drill and drilled a smaller hole to accommodate the tap. Then I repeated the process for the second one. I tapped the bottom of the hole with the matching threads so that the titanium pin would fit tightly. Aside from parting something real large off the lathe, hand cutting threads on titanium is right there down at the bottom of my favorite things to do in the machine shop, but I thought that this hand turner on a die would be a good option for this small piece and the few threads that I had to cut, and then check for fit. There was a little bit poking out the other side. The lathe makes short work of it though. A quick little polish on the fine grit belt, and I had things looking nice and smooth. I didn't want any sharp edges anywhere around that harness, just so it doesn't fray over time if it were to rub or anything. I used the bandsaw to cut a slot in the back of the titanium pin, what I refer to as a ghetto flathead. Sort of just freehanded this tank placement of things. I thought about where other things were going to go and where would be a good spot, and I actually put a lot of thought into this before I did any marking or measuring or welding. Yeah, TIG welded the fuel filler neck on, and got ready to put my brackets. Never bent any tube other than just bending something over a 2x4 or hammering something out on an anvil when I was doing some blacksmithing. But this was the first time I bought this tube bender with some Christmas money, and figured out how to put it together, and just started bending some tubes around and making some swing arms, just sort of eyeballing it. These were never meant to be airworthy. These were simply to hang on the machine and make adjustments from there. All it cost me was 4 feet of steel tube. And you know, if they ended up working, then good. And just FYI, these did not work. I had to make another set. The harness I used was a takeoff from someone else's unit. It's an APCO SLT harness. These are climbing slings I had sewn up by Ryan Yates at Yates Gear. The climbing slings, the little blue things right here that I'm playing with, are rated for 22 kilonewtons, which is roughly 5,000 pounds. You double them, you get 10,000. Yeah, I'm not so sure about this. Something's just not quite right. Back to the bending machine. I needed to drill a hole inside of the filler neck so that I could put fuel into the tank. I had this piece of scrap steel. I think it's just some hot rolled I had laying around. And I'm just going to make a little drilling jig so I could put a pilot hole exactly in the center of the filler neck. Yeah, 10 thousandths undersize gives you a perfect slip fit. Also got to add a new tool to the arsenal. This is a step drill. I've never used one before. This is my first time, but I think I know just what to do with it. Yeah, sorry about that. GoPro died, but they worked out perfectly. It's time to put on the hoop, and I'm calculating the circumference. How big do I want this thing? What are my clearances? Here's the tube roller. I decided on a horizontal rolling of this tube, and I guess I lost some of the footage there, but yeah, everything worked out. It was first try, win, and time to jig it up and see what we're cooking with. I decided on ultra high molecular weight polyethylene for the net. It's thin and it's very strong. This stuff is 150-pound test. And it's sub-millimeter diameter. I'd have to go look at it to tell you exactly. I don't remember. Bought a Loomis needle for about $5 on the internet and watched a YouTube video about how to tie a mesh knot. And that's it, man. Through the loop, pull it tight, hold the line, come around behind the two, pull it, throw your loop, come in between the two, lock it, boom. Repeat 1,043 times and you will have a completed net. As with anything in the shop, if you'll put in the proper amount of time with pen and paper and calculator and just a little staring at it, you'll save yourself a lot of hassle versus just starting cutting and sticking stuff together. It's amazing what you can do with a protractor, tape measure, a little bit of geometry. And everything seemed to fit up exactly as I calculated. Taking this thing apart and put it together probably half the number of times that I'm going to. Had to come up with some fancy jigging solutions for putting these things on. Again, lots of clamps, lots of prep. If you get it where it needs to be to begin with, it'll be good for when you decide to weld it on. And I just took my time, made sure how I liked it and that it was sturdy before I tacked it. My TIG welding skills have improved quite a bit over this project. Got quite a bit of practice in, actually. I'm putting things where I want them the first try. Check this out, left-handed welding. I'm glad I practiced that because it put me in a better position to put these tacks on. Or how about the standing weld? Oh yeah. How about that, Woody? I'm an ambi welder. Don't forget to practice your sats to the left, buddy. Once I got the hoop supports welded securely to the tank, it was time to see if my hoop really held the clearances that I calculated. The angle of dangle. I don't want to hard attach it yet, so I'm just going to put it on with some tape and get a good idea of what's what, basically. Once you weld it, it's harder to undo it, so we're just gonna loosely put it together and do our reassembly and try it on for the first time. Don't make any judgments here. The hoop is lopsided and it's a little off center, but so is the motor and the propeller, so all that's on purpose. As noted previously, the swing arm design was not all that, so I'm trying a couple of different things out. I've got the titanium sitting on the side. I'm just gonna waste this steel. I mean, it's $20 worth of steel. I'm just gonna bend a few pieces and try out some different swing arm options and see what happens. And of course, my card filled up right here, but I caught the last 2 seconds of the hang, so I can actually see where my thrust line falls and figure it looks like it's just under the fulcrum, so we still might play with it. So that's where I'm at with it, guys. I'm gonna make this probably a 3-part video. This was part 1. Part 2 is gonna be the fine-tuning stuff, the connections, you know, the final welds, throttle, flight deck, in-flight carburetor adjustment. What else am I doing on this thing? I don't know. I may think up with other stuff as I go along. I'm gonna get it all sorted out. I know a lot of you have been waiting on this, so hope you enjoyed this video. Like, share, subscribe. Love you guys. Kyle out.